Let me begin with a question. Is formal education for life at school or for life after school? I hope you'll agree with me that formal education should be for life, to enable a person to do well at work, at home, or wherever one happens to be. Take a moment to visualize those places where you spend most of your time as an adult. Let us ask a few more questions. What are the things you need to know in order to do well? At home, at the place of work, when making a decision, or in short, when developing as a citizen and a professional? Is there a connection between those things in life and what teachers grade students for? Well, when was the last time you were tested with a 2-hour examination? When were you asked a question by someone for which you were prepared by the same person? In short, are those well-rehearsed methods and memorized facts, emphasized throughout the educational system, connected in some way to the ways and means of one's life later? At the Republic Polytechnic, we do not unduly concern ourselves with the specifics of the now unknown future workplace of a student. Instead, we focus on enriching and shaping the minds of students so that they can adapt, adopt, and learn well, whatever needed at each stage of life, throughout life. Our strategy is to focus on ideas and patterns, whereas methods and processes we take as incidentals. We have implemented a daily routine common across all formal modules. In the morning, students receive what we call a problem, which is a description of a scenario that requires an investigation. Students are guided by a facilitator who handles a class of 25 students for the day. Students work in teams of 5 each. To assist students to progress towards a conclusion during the day, we provide educational scaffoldings, which normally give useful information as well as pose further questions. The processes of problem interpretation, gathering information, argumentation, peer teaching, and solution presentation are emphasized at different stages of the daily routine. Let me show you a problem that will trigger some thinking and some learning too. Indeed, this is a problem we use in our basic sciences module for our first year students. These are 2 identical weighing scales and 2 identical beakers. We have reset the weighing scales so that it will show 0. Because the setup is identical, anything else we do, it will show on the weighing scales. By the way, this is a weight hanging from above, so it has no connection to the weighing scale. Its weight is not recorded on the weighing scale because it does not touch anything. Now, let me add some water. This is 400 grams and that is 400 grams. I'm going to add 400 grams here, and there it is. The weighing scale should show 400 grams. Let me add another 400 grams to this beaker. So 400 grams here, 400 grams here, and the weighing scales also show 400, 400. No problem. It all agrees with what we normally think. Now let me add 1 liter here, 1000 grams. Here it goes. So as you expect, approximately 1400 grams, and let me add this 1000 grams to this beaker. Now we have a problem. We added 1400, 1400. This one shows 1400, correct. But this one, very close to 1800. The weights are not equal according to the weighing scale. We added equal amounts, we all saw it, but the weighing scale is telling us a different story. This is 1400, this is 1800. Why? That is actually the problem. Let me provide you a little help. This water level is higher, this water level is lower. I can add some more water here to make the levels equal. Okay, it is approximately equal. Now, the weighing scales also are equal. Water level equal, weighing scales equal. But you put equal amounts? No, this one shows larger weight than this one. This needs an answer. Don't you think so?
Okay, let's avoid the details first. I think the focus should be on the fact that the same amount of water produces a higher weight reading when there's a submerged hanging object.
But what if the object is not hanging?
I feel that the case of the non-hanging object will confuse us more. Can I suggest that we leave it to the end to discuss it later?
Okay, but are we sure that this increase in weight is always true?
She has a point. If someone said that those with more money spend more too, I could say that it may not be true. Some rich people are actually very careful when spending.
I think that we can trust this difference to be always true. Anyway, we should be able to check by testing with different weights.
You see, the trouble with making a statement that one is bigger than the other is that it does not tell us how big it is.
What do you expect anyway?
The thing is, it does not tell us how many kilograms the difference in weight would be, even if we have information like the size of the object and the amount of water.
Hey, remember the situation with equal water levels? They show equal weights. I think we can get something out of it.
Actually, that is true. To calculate the weight with a submerged hanging object, we only have to imagine it with a case of just plain water.
That's a good idea. I think that solves the problem, at least for most part of it.
They're right. That last observation provides us a way of predicting the weight reading by imagining a case of pure water filled to the same level. Maybe if someone can suggest a plausible theory, we will be able to take it even further. For example, we may be able to predict the weight for the case of a floating object instead of an object that is hanging. Then we can check the theory against actual observations. If there is a reasonable agreement between the two, that will enable the theory to stand, at least for the kind of situations considered. Let me suggest a plausible theory. The container believes that it is all water filled up to the level and communicates that information to the weighing scale. That is, for all purposes of showing weight, the submerged part of the object is treated as just plain water. I must say that regardless of how silly this theory may sound, it can still stand up to scientific scrutiny, believe me. The way the observations are organized and analyzed, enabling one to reach a satisfactory conclusion, determines the educational value of the exercise. Developing the ability to reason has more long-term value than getting students to memorize a fact, a formula, or a method, or mechanically carry out a calculation or an operation. Developing the ability to reason is what we set out to achieve at the Republic Polytechnic.